What's the toughest case at REWA Lab? It's the dilemma between risk and value. Just like this Samsung repair case, this S23 Ultra refuses to charge. We'll start by connecting a USB-C test board. This enables us to rapidly pinpoint the compromised traces. Diode readings confirm that most charging-related traces are within normal parameters. However, once we probe the VBUS trace, we get an abnormal reading. It's shorted. We need to tear down the device for a detailed power input trace investigation. We'll place it on the heating pad at 90 degrees Celsius for 1 to 2 minutes to soften the adhesive. Fortunately, the back cover and wireless charging assembly are separate, making the initial entry clean and controlled. Before removing the motherboard, remember to place a protective cover over the rear cameras to prevent any micro scratches. Disconnect the flex cables, and the motherboard is out. Using the Bitmap, we've identified the VBUS terminal on the FPC connector, and here it is. The readings here remain abnormal, confirming a fault in the power input trace. But the question remains, has the output trace survived? We'll check the corresponding points on the bitmap. The output circuit is located underneath the shield on the back of the motherboard. To protect the components from secondary heat damage, we'll skip the heat gun and use a precision grinding pen instead. This greatly minimizes the risk of damaging components under the shield due to uneven heating. The readings here are normal, meaning the output circuit is intact. To rule out any interference from this small capacitor, we'll apply Kapton tape and gently desolder the component before retesting the input trace. Still shorted. We now have a clear answer: the fault lies within the motherboard's internal layers. Now, we face a tough choice. According to standard procedures, we should split the motherboard to repair. However, Samsung's motherboard separation is notoriously difficult. Let's use another S23 Ultra board for a demonstration. Our tests on the S20 series and beyond show that these motherboards use a large amount of high-temperature solder paste in the middle layer. Melting it requires long time and sustained heating. Prolonged exposure to such high temperatures can easily cause the CPU and UFS chip pseudo-soldering issue. Once the CPU or UFS chip is tampered with, the phone is considered heavily repaired, and its resale value will plummet. Is there a way to fix this without splitting the board? After our technical review, our team came up with a jumper wire solution. First, we'll unscrew the bottom speaker. As demonstrated, since the VBUS trace is effectively dead, we can bypass the fractured VBUS trace by running a direct jumper wire between the flex cable connector and the output circuit's protective inductor. This is how the jumper wire solution is represented on the schematic. However, this repair also carries risks. Wire can be fragile, a sudden impact could cause them to break. We decided to inform the owner of the situation, and he agreed to the jumper wire solution. Apply a proper amount of flux to the output inductor and use 0.1 mm enameled wire for soldering. Clean the connection with a sponge. Once secured, cover it with green oil and cure it with UV lamp. This insulation armor effectively prevents the wire from vibrating loose. Next, scrape the coating off the flex cable connector. Apply medium temperature solder paste. Then use solder flux and solder it to ensure solid bond. Again, clean it thoroughly and apply the UV mask for insulation. Use the multimeter to verify that the readings are back to normal. And, of course, don't forget to solder that small capacitor back. Finally, we'll apply a piece of high-temperature tape over the original input pins on the connector. This effectively isolates the faulty power input trace. Snap the flex cable on, it's a solid fit. We'll reassemble the motherboard and reconnect all the flex cables. The charging function is back to normal. We also tested the OTG function, and it remains fine. In a case like this, Do you support a full chip level splitting repair, or this precision jumper wire solution? Let us know your thoughts in the comments.